Problem 20 asks us to find all the zeros of the quadratic function. And then it asks us if there are more than one zeros to separate them with commas. So, in other words, we're finding the zeros or the solutions or the x values. Now, one way we could do this that we know will always work is the quadratic function. But before I do that, or not the quadratic function, the quadratic equation, but before I do that, I'm going to see if this factors, because if it doesn't factor into two nice numbers, then we do the quadratic formula. So I'm going to do my x puzzle here. I'm going to put negative 26 on top and 11 on the bottom. I need them to multiply to 26 and add to 11. So I'm going to list some factors of 26, of negative 26. I've got 1 and 26. Those do not add to 11. I've got 2 and 13. Now, if I take 13 and I subtract 2 from that, I get 11. And if I multiply 2 times negative 2 times 13, I get negative 26. So my factors are negative 2 and 13. Now, this to me was much more, it was much easier to do this than to do the quadratic formula. But if all else fails, you can always rely back on that quadratic formula. So my factors are y equals x minus 2 and x plus 13. I'm going to change that y to a 0. I'm going to get 0 equals x minus 2 and 0 equals x plus 13. This is what we're trying to find. We're trying to find our x-intercepts, our zeros of that quadratic function. So I'm going to solve for x by adding to 2. I got x equals 2. And then on the other side, I've got minus 13, and x equals negative 13. So my answers are x equals negative 13, comma 2. Or 2, comma 13. I like to put them in ascending order. Problem 21 is the same as problem 20. So I'm going to start off with that x puzzle again. I'll have 18 on top and 9 on the bottom. Again, it wants us to find all the zeros. This is the same as finding those x values or those x-intercepts or our solutions. So 18, I've got 1 and 18 are factors. Those do not add to 9. 2 and 9, those add to 11. 3 and 6, those add to 9 and multiply to 18. So those are my factors. And I will get 0. 0 equals x plus 3 and x plus 6. Then because of the zero product property, I'll set 0 equal to x plus 3 and 0 equal to x plus 6. Minus 3, x equals negative 3, and I'll subtract 6, and x equals negative 6. So your answers are x equals negative 6, negative 3. Problem 23 is asking us about the domain and the range. If we recall from class, we discussed that the domain is another word for our input values or our x values. So we will put the x values into our quadratic, those are our input, and our output becomes our range or our y values. We often see this used in a t-table. So if I am looking at my graph, I know that these arrows will continue on. These arrows here will continue on this way forever and continue on that way forever. So if I'm looking at my x-axis, I know that any x value I pick, I will get an output. So any x value that I plug in, I will get an output. I can choose any value for x and it will land on our graph. So that gives our domain an answer of all reals or negative infinity to positive infinity. or all reals, as in all real numbers. Now, if we're looking at our range, you can turn your graph to look at it the same way, or I like to look at this from bottom to top and see what points will land on our graph. So if I'm looking at this from the bottom to the top, I know that it starts here at +3 and continues on for infinity. So I will be able to pick any point, any y value from 3 to infinity. So that leaves our range with 3, infinity, or y is greater than or equal to 3. Problem 24 is the same type of question as problem 23, where it's asking for the domain and range. If you recall, the domain is asking our input values or our x values. And our range is asking our output or our y values. If we look at this graph from left to right along the x-axis, because these are all of our possible x values, at first, just looking at this, it looks like it stops here and here. But I know that these arrows mean this graph continues on for infinity. So if I'm looking at that domain and range from left to right, I know it is going to go from negative infinity to positive infinity. You can also write this as all reals. If we look at the range, again, we're reading this from bottom to top, from negative infinity to positive infinity, but we're looking at our y-axis because our range is our y values. So if I'm looking at this from the bottom, I know it goes from negative infinity, but it stops here at -4. So that is going to be read as negative infinity to -4, or y is less than or equal to -4. And those are your two answers.